sorry. And I was talking this whole time, and I didn't have the mic on. All right, sorry about that, y'all. Okay. Antonio, better? Yeah, okay, excellent. Sorry about that. Okay, so let's take a look here. So now what I'm going to do is I'm going to come back and I'm going to rewrite my answer like the way they're asking me to do it here. So we're going to say f of x is equal to, look at the first thing they write. They write x minus k. So I'm going to write it x minus, look what my number k is. K is a -1 times q of x. This part right here, y'all, is going to be my q of x. Remember what we used to have? We used to have an x to the third. So because we divided by an x, we reduced it by 1 power. What that's telling me is that this number here is the number in front of my x squared. This number here is the number in front of my x. And this number here is my constant term, okay, plus the remainder. My remainder in this case is a -7, so I'm just going to put a -7 after that. I want to make sure that it doesn't look like it's all part of the same thing. There we go. And so I'm going to just kind of rewrite it up here, y'all, a little bit neater. So look, instead of writing an x minus -1, I'm going to write it like this: x plus 1 times 2x squared minus 1x or minus x, whatever is easier, plus 2, and then -7. Okay? And that's how I write my answer. Okay? So again, look, this is number 9. So I'm going to come back to my problem in my lab, and I'm going to go to number 9. Okay, so remember what we had? We had parentheses x plus 1, and then parentheses 2x squared. And we had a minus x, and what else? Plus 2, plus 2, and then we had a -7 at the very end. Okay, so I'm going to go ahead and go chickadee check, and we got it. Okay, so that's all that they're really asking me to do. It's sort of, again, that idea, y'all, of when we would divide like this, we would say that the whole number 9 was equal to 2 times 4 with the remainder. Okay, it's kind of the same idea, except now we're applying this to polynomial type stuff. Okay. Alrighty. So let me put up problems like 10 through 12 up here and see if anybody has any questions from any of these 10 through 12. And then y'all, I can go back and look at some of the other ones that we kind of went over earlier. I know we had done 7 and 8, and we had done number 1. Sorry, the volume's not going to come out for those 3 problems because I just forgot to turn on the mic, but anything out of 10, 11, or 12 that anybody has? All right, let me scroll a little bit more. Which one? 13. Let's go over 13, definitely. Okay, so 13 says, let's factor f of x into what we call linear factors, given that k is a 0 of f of x. Okay, so y'all, we're going to do this problem just like the way we did number 9, okay? So first thing I'm going to do is I'm going to look at my polynomial here. I'm going to use synthetic division. I'm going to write down my numbers, which are 3, 5, a -24, and a 16, okay? And since this is already in the form, right, this part right here is already in the form k equals 1, I don't have to change my sign, okay? The sign's already been changed for me. So first thing we're going to do in synthetic division, we bring down the first number. So I'm going to bring down the 3, and we're going to multiply it. 1 times 3 is 3. We're going to add those numbers together. That's going to leave me with an 8. I'm going to multiply again. 3 times 8 is 24. And when we add these together, let's see, this is going to give me 0. Oh, why is this not working out the way I want it to? Got to do something wrong. Bring down to 3. 1 times 0 is 0. It's supposed to be a 0. Did I do something wrong? 3, 5, negative 24, 16. Equals 1. Bring that down. Ah, I know why. Oops. I didn't multiply correctly. Let's see. Okay, what's 1 times 8? 8. Okay, I was putting 24. I was getting ahead of myself there, y'all. I don't know what I was thinking. Okay, so now I'm going to add together. Here we go. This is better. This is a negative 16. So now when I multiply 1 times negative 16 is a negative 16. There's my 0. Okay, that's what I'm looking for. All right. Okay, so look, now that we've done that, since they told me that k is equal to 1, I can think of that, y'all, as x is equal to 1. Okay, whether it's k or x, same sort of idea. Remember, the factor that I'm going to have, if I were to move that 1 over, that factor would now become an x minus 1, right? So all I'm saying is that's going to be one of my factors. Let me kind of clean this up, write it a little bit later. X minus 1. That's going to be one of my factors, okay? Now, just like I said earlier, because this was an x to the third polynomial, and we reduced it by a power of 1, this is now a 3x squared plus an 8x minus 16, and we're going to set this thing here equal to 0. Okay, and so the first thing we're going to do is we're going to see if we can factor this thing out, okay? And we actually don't even need to set it equal to 0. We can just factor it because we're just trying to find the factors. So look, first thing I'm going to do, 3 times negative 16. 3 times negative 16 should give me a negative 48. So what I'm going to do now is I'm going to make a list of all the numbers that I know multiply to 48. Like what? Oh, I don't know, like 1 and 48, like 2 and 24, like 3 and 16, like 4 and 12, and like 6 and 8. And I think those are all the numbers that are going to multiply to a 48. But since it's a negative 48, one of those, in those pairs, one of those numbers is going to be negative, okay? The way I can figure out which number is going to be negative is if you look at this term right here, the middle term, since the middle term is positive, that's telling me that the bigger numbers will be positive and the smaller numbers will be negative. Okay? And what I want to do is I want to find the pair that multiply to a negative 48. They all multiply to negative 48. But I want to find the pair that when I add them together, y'all, I'm going to get the number 8. Negative 4 plus 12, if I owed you $4 and I had $12 in my pocket and you said pay me and I gave you the $4 that I owed you, I'd still have 8, right? Okay, so now we're going to factor this part. I'm going to do this on the side because I'm kind of running out of room here. So I'm going to put 3x squared minus 4x plus 12x minus 16. And then I'm going to put a box around these two right here. And we say, look, what do they both have in common? They both have an x. And I'm left with a 3x minus 4. And then I'm going to look at these two pieces right here, 12x and 16. And I want to think of what number goes both into 12 and into 16. And I want to think of the biggest number that goes in. So I know I can divide them both by 2, but we can also divide them both by 4, right? Okay. So 4 goes into 12 3 times, 4 goes into 16 4 times. Now, if those pieces match up, y'all, that means that we did this right. So they match up, we're doing this right. This is a 3x minus 4, and then these two together give me my second factor, x plus 4, okay? So all I'm going to do now, this is a 4, looks like kind of like a y, but it's supposed to be a 4. So all I'm going to do now is I'm going to copy this part right here, 3x minus 4 and x plus 4, and I'm going to paste it right here next to it. And I'm kind of running out of room, so I'm just going to rewrite it over here. So we had an x minus 1, a 3x minus 4, and an x plus 4. And here we are in our factored form. So I want to mention something, y'all. If I look at 13 and I look at 14, those two problems are really similar. The main difference between 13 and 14 is that in 13, they just want me to factor it out. In 14, they want me to find all the other zeros, right? So we knew in 13 that one of those numbers, we knew that that k equals 1 was a 0. We used that so we could bring down our x to the third polynomial to an x squared polynomial, and then we just factored it out and we stopped there. In 14, we're going to go an extra step. So I tell you what, let's do 14 as well, because again, I want you all to see the difference in 13 and 14, okay? So let's take a look at 14. It says, given that 2 is a 0 of the polynomial function f of x, find the remaining zeros. Okay, so first thing I'm going to do, I'm going to write this down somewhere over here on the side where I got some space. So f of x is equal to, and I'll tell you what, before I do that, this was number 13. Let me go actually to number 13, and let's enter that in for our answer. Okay. So remember we had an x minus 1, and we had a 3x minus 4, and we had an x plus 4. Okay, so I wrote them all there. We're going to check it, and we got it, okay? All right, so let me go ahead and do the same thing for number 14. So x to the third minus 8x squared plus 25x minus 26. Yeah, same numbers. X squared, x to the third minus 8x squared plus 25x minus 26. Okay, and then what do we know for our 0? They're telling us that 2 is a 0, the polynomial function, okay? So look, I'm going to do this problem now the same way we did the other one. First thing I'm going to do, write down this part, 1, negative 8, 25, minus 26. They told us that one of the zeros was 2. That means that x is equal to 2, okay? So again, when it's already in that form, x is equal to 2, I don't need to worry about changing my sign. I'm just going to put that right there. And what I'm going to do now is synthetic division. Bring down the 1. Multiply. Oops. 2 times 1 is 2. Add them together, that's negative 4. Multiply. 2 times negative 4 is negative 8. 25 minus 8 is a 13. And then multiply one more time. 2 times 13 is 26. Add them together, they're 0, right? That's what we're supposed to be getting because they told us that that number was one of the zeros. Okay, now that we have that part, are we good? Out of that, Aridai? So when I'm, oh, this, you know what? I made a mistake, didn't I? Man, what's wrong with me today? I'm sorry, guys. Okay, so this is a 2, this is a negative 6, isn't it? Okay, that's better. 2 times negative 6 is a negative 12. Here's my 13. And 2 times 13 is my negative 26. That's right. That's better. Much better. Sorry about that, y'all. Okay, so now that we have this part, remember, we've reduced our polynomial from an x to the third. This is now going to be an x squared, right? So I have an x squared, a minus 6x, and a plus 13 equals 0. Okay? And so now what I'm going to do is I need to see if I can factor this thing. So if I'm going to factor it, if I'm going to try to factor it, my first step is to say, look, the number here is a 1, okay? So 1 times 13 is 13, and I'm looking for two numbers that multiply to 13. Well, the only numbers that I know that multiply to 13 are 1 and 13, but when I add them together, they don't give me the -6. Okay, well, that's all right. What we're going to do then, y'all, since factoring is not going to work here, we're going to use the quadratic formula. Okay, remember my A is 1, my B is a -6, and my C is a 13. Okay, and I'm going to write down my formula right here. X equals -b plus or minus b squared minus 4ac, all over 2 times a. So let's see. First step, y'all, I just do the plug. Negative. Negative. Okay. B is a number in -6 plus or minus b squared -6 squared minus 4 times a, which is 1, times c, which is 13, all over 2 times 1. Okay. And let's see what we're going to end up with. Let's see. Negative and negative is a +6 plus or minus. Let's see. -6 when I squared is a +36. I'm going to do this part here on my calculator, y'all. So I have 4 times 1 times 13. Let me turn this thing on. Okay, clear it. 4 times 1 times 13. That's a -52. There's a minus in front of it. All over 2. Okay, so x equals 6 plus or minus, let's see, what is 36 minus 52? 36, 52, -16, all over 2. All right, almost done. 6 plus or minus. Okay, so we got to take the square root of -16. We did this like in August. So I know it's been a long time, but the square root of 16 I already know is 4, right? Because there's a negative on the inside, y'all, that's where that I comes into place, okay? All over 2. Now, since this is everything is being divided by 2, I'm going to divide each of these numbers here by 2. So this is going to be 3 plus or minus 2 with an I. It's supposed to be an I. Okay? Now remember what this means. It really means that there's 2 answers here. One of them is 3 plus 2i, and the other one is 3 minus 2i, okay? So I know I had to use the quadratic formula, but we know the quadratic formula because we did it a whole bunch of times. So I'm going to show you something. When I come back to my answer, and again, y'all, you can write it either like this, or you can separate them. The only reason I separate them is just to kind of show you that that plus or minus really means that there's 2 parts. So one of them where you add and one where you subtract. Sometimes people look at it and say, oh, it's just one answer, but plus or minus means 2 different things, right? One you add, one you subtract. So what I'm going to do is I'm going to come back to my problem over here. Here we go. Okay, so the question here is saying, can we list the remaining zeros other than 2? So I don't need to put 2 again. They're saying, what are the other ones? Well, the other ones are 3 plus or minus 2i, okay? And notice what it says. Type an exact answer using radicals and I as needed. Well, we had to use I, okay? And use a comma to separate them. So I'm going to check something out here, okay? I'm going to see if I can just do the plus or minus, and if it doesn't work, then we'll separate them. So we're going to go 3 plus or minus 2 with an I. We're going to check it, and we got it. Okay. So the one thing I really wanted to mention, what was different from, and let me come back to my notes, what was different from 13 and 14. 13, they wanted me to list every single factor. So we did. We put it as x minus 1 because that was the first zero they told us was k equals 1, so x equals 1. So we wrote the factor x minus 1, and then we factored the rest of the problem right over here, this 3x minus 4 and x plus 4, right? And so we wrote it out there. This one is saying, okay, we already know one of the zeros. Can we find the other 2? So we did synthetic division over here, right? And then when we got to this step, since it didn't factor, we used the quadratic formula, okay? Now, y'all, I want to mention something. Anytime you're finding the zeros, if you don't want to mess with factoring, And as long as it's the highest power you have is an x squared, you can always use the quadratic formula. The quadratic formula will work every single time. It's kind of like a master key, right? It'll open up every single one of them. The quadratic formula will solve any one of those. So if you don't really dig on the whole factoring thing and you're like, you know what, it's not for me, then use the quadratic formula. It'll always work. Just be careful, make sure you find your A, B, and C. Go real slow. Remember, my first step is once I write down my formula from here, right? Always write down my formula. This part here, y'all, I don't try to simplify anything. I just put the numbers where they go. And then I start simplifying because you can see I already made 2 mistakes tonight, right? So I don't want to make a mistake here, right? And trying to do too many steps in one. But the answers are going to work out nice and pretty anyway. These are excellent questions. I'm glad you guys are asking them. So y'all, I want to do number 15, and then I'm going to skip around, and I'm going to find another problem that I want to do as well. And I'm not certain you guys had 15, but I want to do these 2 problems because I kind of want to show y'all something. So look, number 15 says, find a polynomial of degree 3 with real coefficients and zeros of -3, -1, and 4, for which f of -2 is equal to -30. Okay, so let me tell you what we're trying to do. We're trying to find a polynomial of degree 3. That means in our problem, y'all, we're going to have an x to the third. I don't know what it's going to look like, but it's going to be an x to the third. That's what they mean by degree 3. Okay, so they told us what the zeros are. That means the first zero is x equals -3. The second zero is x equals -1. And the third zero is x is equal to 4. So these here, y'all, are my zeros, okay? What I'm going to do now, I'm going to write out the factors, okay? So, excuse me, remember how I write the factors? I just take these numbers, excuse me, and I bring them across the equal sign. So now I'm going to have x plus 3, x plus 1, and x minus 4. And all I'm doing is, since I'm crossing the equal sign, the sign of my numbers are going to change, okay? Now, once here are my factors. So now I can start to write out my polynomial. It's going to look like this. F of x equals a. There's going to be some coefficient. I don't know what it's going to be, but there's going to be a number in front of the whole thing, okay? That number could be 1. It could be, 1/2. It could be -8, something like that. I don't know yet. And I'm going to write my 3 factors. X plus 3, x plus 1, and x minus 4. Okay, so look, we've used this number, and this number. This is the part that we got to do next. So remember, when it says f of -2 equals 30, or -30, I'm sorry. Remember what this means. This is the number that I'm plugging in for x. That's what my answer is for y. So what I'm going to do here, y'all, is I'm going to put a -30 equals a, and everywhere I have an x, I'm going to plug in the number -2. So I'm going to put -2 plus 3, -2 plus 1, -2 minus 4. Okay? So if you notice from here, y'all, the only number that I don't know yet is that value of a. So let's go slowly. -3 equals a. Let's see. -2 plus 3 is 1. -2 plus 1 is a -1. And -2 minus 4 is the -6. So -30 equals a. Let's see. Actually, we'll do it like this. We don't need to put 3 parentheses. -1 times -6, +6, right? Times 1 again, still +6. So if I'm trying to solve for the letter A, what I'm going to do is I'm going to divide everything by 6, and A is going to be equal to a -5, right? Okay, so last part, what I'm going to do is I'm going to come back to this problem right here, y'all, and I'm just going to replace the A with the number -5. Okay, so I'm going to write it, oops, let me erase some of this mess. I'll write it over here. So f of x equals negative 5 times x plus 3, x plus 1, x minus 4. Okay. Now, before I finish, I want you to notice something about the problem. Where is it? Right here. This is number 15. Look what it says. It says do not factor. And when I look at this part here, y'all, what I have written in the green, this is factored right now. So what I'm going to do is I'm going to do a little bit of work. Okay. Let me go like this just to kind of block everything else out. Okay, let me multiply these parts out. So that's going to give me an x squared. That's going to give me a plus 1x. That's going to give me a plus 3x. That's going to give me a plus 3. And then I have my x minus 4 over here. And I tell you what I'm going to do, y'all. Because when we're multiplying, what number we multiply first, second, third, it really doesn't make any difference. I'm going to take this negative 5 times this x minus 4, okay? So I'm going to distribute that. That there is going to give me a negative 5x and a plus 20. And then now let me combine my like terms here. So this is still an x squared. 1x plus 3x is 4x. And then plus 3. Okay? And now I got to distribute one last time. Okay? So let's go for this. F of x, and we're going to go one last time. So look, negative 5 times negative 5x times x squared. This is a negative 5x to the third. Negative 5x times 4x is a minus 20x squared. Negative 5x times 3 is a minus 15x. Okay. And then I'm going to do this one. So 20 times x squared is a 20x squared. 20 times 4x is a plus 80x. And 20 times 3 is a 60. Okay. So look what we got now. We got a negative 5x to the third. Take a look, y'all. These x squareds are going to cancel out, right? And then minus 15 and plus 80. If I take my calculator, turn it on, negative 15 plus 80, those are the numbers in front of my x's. That's a 65. So that's a plus 65x and then plus 60. This is what they're asking me to do. When it says do not factor, they want me to go through that extra step and multiply everything out, okay? So this is what I'm doing, and I'm coming up with negative 5x to the third plus 65x plus 60. And I'm going to come back to my problem here. Let's see, I think it was the next one. Yes. And I'm going to write negative 5x to the third. And we had a plus or minus. We had a plus 65x and a minus 60. No, yeah, plus 65x and plus 60. They're both positive. And a positive 60. I'm going to go check. And we got it, okay? So again, this problem, y'all, before I do anything else, I want to point out, what did we do? We knew what our zeros were, right? They told us the zeros, so we wrote out the zeros right here. Then we wrote them as factors. We wrote out our polynomial. And then given this piece of information right here, we found our value of A. We wrote it out right up here. And then the part that took me the longest, I think, was having to go through all of this extra stuff, right? Now, I told y'all I was going to do another problem similar to this one. So the one we just did right now, this was number 15. Let me see if I can find the one. Here we go. Okay, number 18, y'all, is almost identical to number 15. Okay, so look what it says. Find the polynomial of least possible degree, meaning the smallest power of x, that has this graph. So I want you to look at the graph. If we look at the graph, right here, 1, 2, 3, I see 3 x-intercepts. Those x-intercepts, y'all, are the same thing as the zeros of the function. So look what we have. We have our zeros. I'm going to write them out. X equals the first one, -6. X equals the second one, 3. X equals the third one, 8. The x-intercepts are the same thing as the zeros. Now, just like we did before, we're going to write out the factors. So I'm going to take each of these numbers and I'm going to bring them back across the equal sign. Okay? So this is going to be an x plus 6, an x minus 3, and an x minus 8. Okay? Again, it's what we just did a little while ago. Now, I want to find my polynomial. So the way I'm going to do it, I'm going to go like this. F of x equals a, just like we did before. We found that a number. X plus 6, x minus 3, and x minus 8. Now, if you look at the picture that we have here, y'all, look at the points that I've already labeled. The one that I haven't yet touched is this one right here, right? Remember, the first number is the x, and the second number is the y. So this is telling me 72 equals a. Look at what the x number is. The x number in this case, y'all, is 0. So I'm going to put 0 plus 6, 0 minus 3, 0 minus 8. Okay, so 0 plus 6 is 6. 0 minus 3 is -3. 0 minus 8 is -8. All right, so now I'm going to take my calculator because I need to multiply 6 times -3 times -8. 6 times -3 times -8, 144. Okay, so then I'm going to say, oops. Come back, here we go. I'm going to say, what happened here? Okay, so I'm going to say 72 is equal to 144 with an A. I'm going to divide both sides by 144. And those of you who have one of these calculators or even the calculator app, it should work. Look, if I take 72 divided by 144, if you're using one of those apps, y'all, it reduces it for you automatically. In this case, it's 0.5. And I know that 0.5 is 1/2, but if you weren't certain, like if it gave you a decimal and you weren't sure what it was, you can always hit the button right here underneath the alpha button. The button says math. And if you look at the first one, it says fraction. So just hit enter. It's going to convert that decimal to a fraction for you. And it's 1/2, right? So obviously 0.5, most of us know it's 1/2. But if it was like 0.365, what would it be? That's all you're going to do. So my A number is 1/2, okay? So now what I'm going to do is I'm going to replace that number with a 1/2. So I'm going to say, look, f of x is 1/2 x plus 6, x minus 3, x minus 8. This one here does not say anything about, oh, look what it says. Write your answer in factored form. At this stage, I'm done, y'all. That's my answer, 1/2 x plus 6, x minus 3, x minus 8. So I'm going to come back here. This was number, I think it was like 16 or 17, 19, 18. Let's go to 18. Here we go. So first I'm going to do 1/2, and then x plus 6, x minus 3, x minus 8, and I'm going to go chickadee check, and we got it, right? So I'm going to ask you all a question. Do you see the similarities between 18 and 15? Do you see how they're almost identical? Which one is easier, do you think? This one here or the one we did earlier? This one here. Okay, so when you take your test, whenever you take it, whether you take it today, tomorrow, or the night before Thanksgiving, which one of those problems do you think I put? The first one or this one? There you go, right? Why? It's the same thing, except this one is just making us do all that factored, all like multiply everything out here, right? it's an extra step, and it's not like one little step. It's a lot of, you know what I mean? You got to distribute this and this and this and this. And obviously, like with the one that we did here, look, we had a -5, right? So if for whatever reason you put a +5, your sign changes, something like that. There's so many little places where we can make our mistake. And so this is why I really like this one here, or this one here, y'all. This one here is almost identical to the one we just did, okay? And I'm going to set this one up for y'all. And if you want me to go through it, we'll go through it completely, but I at least want to set it up for you. But 18 and 19, y'all, are almost identical type problems, okay? And so look, let me set up number 19, and if you want us to go, if you want to, we want to finish it off, we'll definitely finish it off. Okay, so it says, find a polynomial function f of x of least possible degree having the graph shown. So remember, just like the way we did before, I'm going to mark my x-intercepts. So one of them, we're going to write our zeros. One of them is x equals -5. The other one is x is equal to 3. Y'all, we actually have a second one here. So even though I look at my picture and I see those two, this is what I want to point out to you. Let me get my blue marker here. Okay. If I'm tracing the graph, do you see how the graph hits this and it bounces off? Anytime it hits the x-axis and it bounces, like it doesn't cross through, but it does a little bit of this action, whether it comes from the bottom and goes up or like this, okay? This one here is going to occur 2 times. Anytime it has the bounce. So if it hits it and like bounces off, wherever it hit it, it's going to occur twice. Anytime there's the bounce, okay? They're my zeros. Let me write my factors. Bring each of those numbers across. X plus 5, and both of those are going to be x minus 3. If you want to, you can write it like that, x minus 3 whole squared, okay? And then just like we did before, we're going to start out writing our problem. So we're going to say, look, f of x equals a, x plus 5, x minus 3 squared, right? And then remember, I still have this number right here, the 0 and the 9. Remember what that means? That's the number for x, and the 9 is the number for y. So what am I going to do? I'm going to come back over here, and I'm going to put 9 equals a, 0 plus 5, 0 minus 3 squared. 9 equals a, 0 plus 5 is 5, 0 minus 3 is a -3, but that's being squared. Okay, so this is still a 5. -3 when I square it is a +9. So 9 equals 5 times 9 is 45 with an a. So when I divide both sides by 45, we end up with a is 1/5. Okay. And then now all we have to do, y'all, is come back to this problem right here. And instead of writing it with an a, we can say f of x equals 1/5 times x plus 5 and x minus 3 all squared. And again, it's the same idea. And some people find this problem easier than even 18. Some people find it easier. Some people forget that when you hit right here and it does that bounce, that it occurs twice. Okay, so I'm always kind of like, you know, when I make my tests, I'm like, and I always think to myself, okay, look, I'm either going to ask something like 18 or I'm going to ask something like 19, right? And I think the calculation on 19 is probably easier than it was on 18 to find a. But if you don't put it twice, then it's going to give me a wrong answer. You know what I mean? Because it has to occur 2 times. So again, look, here's my answer, 1/5 x plus 5 squared, or x plus 5 and then x minus 3 squared. So if I go to the next problem here, and I type in 1/5 x plus 5 and then x minus 3, all of that being squared. There we go, and I check it, and we got it, you know. Okay, so I know that I went from like 15 to 18. So I don't know if any of y'all had any questions from like 16 or 17. And if you did, I'm more than happy to go over any of that stuff there. Anything? We good for those? Okay. And then, so we got 20, 21, 22, 23, so on and so forth. So I'll leave these up here, y'all, and if there's anything that you need. 22, let's do number 22. Okay. All right, so 22 says, use a table for f of x to find a table for f inverse of x, and then let's find the domains and the ranges. Okay, so remember what inverse functions do. Inverse functions, y'all, do are kind of like if I drove, like today, I drove from Edinburgh to Westville. The inverse is going to be tonight when I leave here, I'm going to drive from Westville back to Edinburgh, right? So all I'm going to do is I'm going to say, look, I'm going to look at this table right here, and all I really want to do, y'all, is switch the x values and the f of x values. So if it's 1, 4, 7 and 5, 11, 17, then if you just flip them like upside down, the first one should be 5, 11, 17, and the second number should be 1, 4, and 7. So if I look at that, wouldn't it be choice C? Because all we've really done is flip these here. So instead of 5, 11, 17 coming first, those are going to be the ones that come. You know what I mean? Those are my second ones. They're now going to be my first ones. 1, 4, and 7 will be my answers. Right? Okay. Now, what we're going to do is we're going to find, it's asking me, what's the domain of f? So what's the domain of this function here? Remember, the domain, y'all, refers to the x values. So my x values in this case are 1, 4, and 7. Okay. And then it says, what is the range of f? So the y values in this one are 5, 11, and 17. Okay. And now it's saying, what's the domain of f inverse? Well, the domain of f inverse is the range of the original function. So this is 5, 11, and 17. And then the range of f inverse would be those numbers right there, 1, 4, and 7. Does that make sense on what I did? Claudia, are you okay how I chose choice C? Okay. We're going back to the first chart right here, right? So we're looking at this one, and it says, what's the domain? So the domain are those numbers there. So that's why I put 1, 4, and 7, right? And then what's the range? 5, 11, and 17, right? And then now, when I look at what it's asking me to do, the domain of the second one. So the domain of the second one is saying, okay, let's look at this function right here. What's the domain of this one? Well, 5, 11, and 17, right? And what's the range of this one? 1, 4, and 7. Does that make sense? So the domain of one is the range of the other, right? And vice versa, right? So this was number, which one? 23? 22. So if I come back over here, y'all, and I say, look, let's go to 22. So we chose C. There we go. And then we said, what was the domain of the first one? We said it was 1, 4, and 7. Okay. And then what was the range of the first one? We said it was 5, 11, and 17. Okie dokie. And then what's the domain of this one here? Well, 5, 11, and 17. And what's the range of that one? It is 1, 4, and 7. 1, 4, and 7. Boom. And we got it. Good, 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 good. So let me ask you a question. Isn't 23 almost exactly the same? It's just different numbers, right? But the process would still be the same? Yeah. Let's do 24. So it says, use f of x to complete the table for the inverse. Okay, so this is what we're going to do, y'all. In 24, we know that our function f of x is equal to x plus 3. And what we're trying to do is we're trying to find f inverse of -1. So remember what we said over here earlier? Let me come back to this problem here. So if we knew, let me kind of erase some of this stuff here. Okay, so in our original function, if we knew what the y value was here, that would have been the x value previously, right? Okay, so what I'm going to do here, y'all, is I'm trying to find the inverse of -1. So the inverse of -1 in the original function, and this one here, remember, this is the x in the inverse. So in the original function, it really would have been the y value, right? So I'm going to take this x plus 3, and I'm going to set it equal to -1. So when I do that, and I subtract 3 on both sides, let's see, -1 minus 3, I end up with a -4. So right here, that answer would be a -4. And then I'm going to do that same thing again. I'm going to take this x plus 3, and I'm going to set it equal to that number, which in this case is a 2. So when I subtract 3 and I subtract 3, let's see, 2 minus 3, that's a -1. So that's going to be that number right there. And then I'm going to do this a third time. I'm going to say x plus 3 is equal to this number, which is a 5. So when I minus 3 and minus 3, I'm getting x is equal to 2. So that's going to be my number right there. And I'm going to do this one last time. I'm kind of writing all over the place. X plus 3 equals 8. So when I subtract 3 and subtract 3, I'm getting x equals 5. So right here, I'm going to put a 5. So I'm going to come back to 24 in my homework. Let's see. Let's go like this. Let's see. 24. Okay, so for the first number, we came up with, let's see, -4. Let's see. Here we go. So -4. We're going to check it. Excellent. The second number we came up with is -1. So right here, y'all, we're going to go -1. We're going to check it. All right. The third time we came up with 2 and then a 5. Okay. So here we got a 2. Perfect. And then here we got a 5. And we got that one too. Okay. All right. So look, y'all, I got 25 through 28 up here. Anybody got any questions on any of these up here? 25, 26, 27, 28? You know, Antonio, I haven't even checked in with you, my friend, to see if you got any questions, but so far it doesn't look like you do. Who else is here with us? Robert is here too. Antonio, Robert, if either of y'all have any questions, you can either put them in the chat or you can just turn on your mic and let me know which ones y'all got. Anything out of these here? 27. Okay, so it says, find the future value and interest earned if $8,906.54 is invested for 8 years, compounded. Part A says semi-annually and Part B says continuously. Okay, so look, y'all, before I do this one here, I'm going to pull something up. Let's see. And I'll talk about next week in a minute, but here we go. Let's go like this. Let me do this number here. Okay, so here you all, I did include the formula sheet for our thing here, for our test here. And so first thing I'm going to do, oh, here we go. Compound interest. So for this problem here, y'all, for number, which one? For number 27, I'm going to use these formulas right here, okay? So I'm going to go ahead and write down the formulas so that I can show you guys how we're going to use it. Okay, so there's one called the compound formula, and the formula looks like this. Okay, now let me tell you what each of these letters stand for. P is the amount of money that we are investing. So in our case, this 8906.54, that's my P. That's the amount of money I'm putting in the bank. Okay, so look, we're going to go like this. 8906.54, and then it says a 1 plus R. R is our interest rate. So if you look here, y'all, our interest rate is 6%, and as a decimal, that's 0.06. What I'm always going to do, y'all, in case, I know it's been a long time, and some of you may remember, some of you don't. When you have 6% like this, always, if you don't see the decimal, it's always understood to be at the end of the number. You're always going to move from going from a regular number or a decimal number to from a percent to a decimal. You're always going to move your decimal 2 spaces to the left. 1, 2. Since I do that, if there's nothing here, I got to put my 0. Okay. Again, placeholder type stuff. The number n. N refers to how many times I'm compounding my money in a year. So when it says semi-annually, that means every half year, right? So if it's happening every half of a year, that means it's going to happen twice in 1 year, right? So my n is going to be the number 2. And then up here, if you notice, it's n times t, so 2 times t. T is my time in years, y'all. So in this case, it's the number 8. Okay, so I'm going to zoom in just so you can kind of see what I wrote. The next step, y'all, is strictly calculator work. You're going to do this exactly like the way it's written on your paper. You're going to enter it in your calculator exactly the same way. So again, whether you have a regular calculator or one of those calculator apps, you're going to enter it in exactly the same way. So look, 8906.54 times, because it's, in front of the parentheses, right? So I see parentheses, so let me write them down. 1 plus 0.06 divided by 2 raised to the power. So I'm going to do this as my power. Look what my power is. It's 2 times 8. So I already know that 2 times 8 is 16, but if you weren't certain, just put your power with parentheses, y'all. 2 times 8. Okay. Enter. And because I'm talking about money, I need to round everything to 2 decimal places. So my answer here would be 14,292.38, because it's the number after the 8 is a 2. So 14,292.38. So 14,292.38. And what I'm going to do is, this is number 27. Excuse me. So 14,292.38. There we go. Fantastic. Okay, now it's asking me how much interest did we earn. So let's take a look, y'all. How much money did we originally put in the bank? We put in $8,906.54. How much did we get 8 years later? That amount. So how much of it is interest? Well, the difference between the two, right? So I'm going to take 14,292.38, and I'm going to subtract off 8906.54, and I'm coming up with 5385.84. 5385.84. 5385.84. Right, yeah, there we go. So look, let me enter this part in here. 5385.84. There we go. There's my, that's how much money we made in interest, right? So we didn't have to do anything, let the money sit in the bank. It took me 8 years, but now I got an extra $5,000. All right. Now, part B says, what is the future value when the interest is compounded continuously? Okay, so let me show you how I'm going to do this part. Since it's talking about continuously, y'all, I'm going to use this formula, the continuous compounding formula, okay? Very similar to the one we just did. So let me write it down. So it is, let me see, let me come back over here because I heard something in the chat. Let's go here. Okay, and Robert, I'll definitely get to number 5 from your quiz, okay? So my formula here, y'all, is A equals P e to the RT. Okay, so I'm still using the same numbers. What was my principal? 8906.54. 8906.54. Then I see this E. This is a number, a function I'm going to use on my calculator. Remember, y'all, my interest rate was 6%. So as a decimal, that was 0.06. And my time was 8 years. Okay. So again, just like the way I have this written here, is the same way I'm going to enter it on my calculator. So I'm going to go 8906.54. Now, the way I get to my E, on my calculator, at least on my calculator, if you look directly to the left, directly above the LN button, there should be a little E, wherever your LN button is. So we're going to go second and LN, and it's going to type in that E for me, okay? Look what my power is. My power is 0.06 times 8. So 0.06 times 8, and I'm going to hit enter, and I'm coming up with 14,393 and 63 cents. So 14,393 and 60, what did I say? 63 cents. Okay, so this is the amount of money I'm going to have in the bank if we were compounding it continuously. So 14,393.63. So right here, I'm going to type in 14,393.63. We're going to check our answer. Okay. Now, again, how much interest did we earn? We're going to use our calculator. Remember, this is the amount of money we have now. How much did we start off with? With that 8906.54. So 14,393.63 minus 8906.54, and I'm coming up with 54.87 and 9 cents. 54.87.09. I'm going to check it, and we got it. So yeah, these problems here, y'all, this is number 27. This is really, I mean, you're using the formula, but once you write down your numbers, the rest of it is just calculator type stuff, okay? So again, y'all, one thing I really want to emphasize, especially with these types of problems where, you know, I mean, if you're sitting there at home, right, and you're using your calculator and you do 3 times 2 and you come up with like 11, you're like, okay, you know what, something is not right because I know 3 times 2 is not 11. But when you're doing this stuff here on the calculator, right, whatever number you get, es la palabra de Dios, right? It's the word of God. We don't ever question it. That's just what the answer is, right? Because it's not stuff that we normally think about. So just be real cautious on your calculator that whatever number you come up with, think about it this way. If you're putting money in the bank and you start off with almost $9,000, you know that you should end up with more than that, right? So for whatever reason, if you're coming up with a number that's less than that 890654, or whatever number you have on your problem, something isn't working out right. Okay, so if you're coming on that, guys, whenever y'all are working on your review, if you're doing this problem, if it's not working out, sir, can you show me how to do it on the calculator? I'll show you how to do it on the calculator. Okay, I just want to make sure that you guys come up with the right answers. All right, excellent, excellent. Any other questions here, y'all? 28, 29? And Robert, I will get to number 5 before we leave for the night. And then guys, let me ask you a question. Weren't we doing problems like 29 and 30? Weren't we doing those the other day, last week, right, when we were here? I'm hoping that some of that is a little bit more familiar now that we kind of went through some of that stuff. Okay. Like I said, y'all, I'm going to put this back up again, and then Robert, I will get to your question. Let me come back over here, y'all. So again, y'all, the test has 20 questions. Those 20 questions came directly from the review, okay? You can use your calculator. You can use the calculator app if that's what you're using, like on your phone or something like that. That's fine with me too. The formula sheet is right there. The test is going to open up tonight. You don't need to take it tonight, right? You're going to have 8-9 days to do it. It's going to be open today until next Wednesday, which is, again, the night before Thanksgiving. So I don't know about you all, but sometimes the Wednesday before Thanksgiving is busier than Thanksgiving itself, right? Especially if you're going somewhere, if people are coming in, even if you're just like, you know what, I got to clean the house because I don't want to have Thanksgiving in a messy house, right? That kind of stuff. So just make sure that you take it when you know that you have time. Y'all, there's a 5-hour limit, okay? 5 hours is plenty of time. All that means, though, is that don't start the test and like, oh, you know what? Let's go have breakfast and let's go shopping and all that kind of stuff, because then you're going to come back, time's going to run out, right? Just make sure you carve out some time when you can do it. Again, I did put until next Wednesday, but again, if you know you're going to be busy that Wednesday, don't wait till that day to try to get it done, okay? Let's see. Let me get to the quiz question number 5. So this is what I'm going to do, y'all. I'm going to come over here. And Robert, I won't actually pull up your problem, but I will pull up the one that's showing up on my quiz here. Okay, so there's 10 questions. Let me get to number 5. Okay, so Robert, I don't know if this looks like your number 5 at all, but let me go ahead and do this one here. And again, if it's a different question, Robert, or a different type of problem, then let me know and I'll do that one as well. So I'm just going to kind of do this over here on the side. Let me paste this right here. Okay. So remember, y'all, anytime I'm doing something like this and it's telling me to write it in exponential form, what I'm going to do is I'm going to use the definition of a logarithm. Okay. So I'm going to look at what I have right here, and I'm going to do a little stare and compare to this part. So if I look at this part here, my 3 is the same thing as my y. So I'm going to say y is 3. My base number a in this case is the number 2. And my x number in this case is the number 8. And so what I'm going to do is, now that I know these 3 parts, I'm going to write it like this. I'm going to say a, which is 2, to the 3rd power is equal to 8. And it says, don't simplify, just write it like that. So let me come back over here, and I'm going to write out 2 to the 3rd power is equal to 8. And let's see, let me come back to over here, and let's see. Robert, just making sure, yeah, it looks like you're still here. Was that the question you were referring to? Was it number 5? Or is that better for number 5? No, that's not the one? Or am I not making sense? What happened? There we go. Okay. Do you remember which question it was? I don't know if you can go into the gradebook, and if you click on gradebook in my lab, Robert, you can click on your quiz and hit review to see what question it was, and then you can let me know. So as Robert is doing that,
yeah, sir, it talks about factoring, linear factors.
linear factors. Okay, so let me see. Let me take a look, and let's go here. Oh man. Was it quiz 4, Robert, or was it quiz 3? Do you remember?
3. It was 3.
Ah, okay. I'm doing quiz 4.
I'm sorry.
Let me get out of here. That's okay. That's okay. So let me do this and let me come back over here. Quiz 3. Okay, I'm already past doing quiz 3 because I didn't do it, but I can tell you what I can do. Let's go here. Let me go over here to quiz 3. Here we go. Here we go. Let's go to preview. And let me click on question number 5.
Yes.
This is the one. Okay, yeah, let's definitely do this one here. And okay, so actually, y'all, this is kind of like the problem that we did earlier this evening on the review. But Robert, I know you weren't here for all of it, so let me go ahead and go through this one as well. Okay, so it says, and again, this is a good question to do, y'all. We did one similar to this earlier tonight, but let's go through this one here. It says factor f of x into linear factors given that -6 is a 0 of f of x. Okay, so step number 1, x equals -6 is one of the zeros, right? Okay, I'm going to use synthetic division. 19, -29, +6. Excuse me. Okay, so now what I'm going to do is I'm going to use this number right out here. Remember, the sign's already been changed for me. Bring down the 4. So -6 times 4, -24. And then let me figure out what is 19 minus 24. -5 is going to be my number here. I'm going to multiply again. -6 times -5, +30. That's going to leave me with a 1. Multiply one more time. -6 times 1, -6. There's my 0, right? Okay, so guys, I'm glad Robert asked me this question. Anytime it tells you that one of the numbers is a 0 and we use synthetic division, that means that my remainder should be 0. If it's not, that means I made a mistake somewhere. Okay, I screwed up somewhere. All right, so remember, we used to have an x to the third. And so now the 4 is the number in front of my x squared. The -5 is the number in front of my x, and the 1 is my constant term. Since we want to factor this thing into linear factors, this is what we're going to do. We're going to multiply. 4 times 1 is 4. Okay. I want to think of all the numbers that I know multiply to 4. 1 and 4, 2 and 2. I want to find the numbers that are going to add up to a -5. Well, look, if I make both of those negative, I still multiply to a +4. And when I add them, there's my -5. Okay, so now let's go ahead and write this out. 4x squared minus 1x minus 4x plus 1. Okay, all I did, y'all, is I rewrote this number using those two. Okay, that's really all we're doing here. Okay, so now let's look at this part, and we can say, what can we take out of there? Oh, we can take out an x. And now we got a 4x minus 1. When I look at this piece here, it doesn't look like I can factor anything out. But if that first piece is negative, let's take out a -1. All that does is it changes those signs. So instead of a -4x plus 1, it becomes a 4x minus 1. Now I told you that if these two pieces match up, we're doing this right. 4x minus 1. The other factor, y'all, is going to be x minus 1. And then remember earlier on, we said, come back over here, x equals 6 was a 0. That means that the factor is x plus 6. And here it is in our factor. Okay. So 4x minus 1, x minus 1, x plus 6. I don't know if it will let me. I guess it will. Yeah, it should let me do it. Let's see. What did I write? 4x minus 1? Yeah, 4x minus 1, x minus 1, x plus 6. Okay. So let's go parentheses 4x minus 1, x minus 1, x plus 6, like that. Boom, and we got it. So, Robert, does that make sense, Robert, how we did this one? I don't know if Robert's still here with us. Yeah, I think I heard something here. Let's go like that. Yeah, you got it, sir. You got it, my friend. All righty. And let's see. So guys, any other questions y'all want me to go over? I don't know if there's anything here that you still want me to talk about. And you know what? I'm actually going to pull 42, y'all. I didn't mean to put 42 on the review, and you don't have anything like that on the test. That was my mistake. So, tell you what, since y'all are still here, let me do this. Where's my review? Here we go. Let's go like this. Remove a question. We are removing number 42. Boom. And all that means now, y'all, is that when I come over here and I go to my assignment and I click on my review, if I go to question 42, number 1, if you notice, I got it right. But when I click on it, that's what it says. The question has been removed. Okay, so don't worry about 42. That was my mistake. That question shouldn't be on there. I need to do that for my other class as well. I'm glad I saw that right now. Okay, so question 42, y'all, not on the, so there's really only 41 questions on the review, and then 20 of them come from the test. Yeah, it's a homework grade, but more importantly, Lauren, what I like about the review is since I base the test on the review, it's kind of like a sneak preview, right? Remember when you go to the movies, you see the previews, and like, oh man, I want to see that one, right? It's already telling you what's going to happen. So all the questions that you're going to see on your test came directly from the review, okay? So y'all, one thing I also wanted to point out, now that I have y'all here, is let's see. Let me go like this. Okay, so right here, y'all, I did, so I know that the test is open tonight and it's going to be open throughout all next week, right? Next Tuesday, y'all, we still have class. I mean, if I know some people might even leave on Tuesday if you're going out of town, that's fine. I mean, I'm going to record everything and I'll send the video out. But next Tuesday, y'all, so I want you to notice here for week 14, we do have one more written assignment, okay? Next Tuesday, y'all, what I'm going to do in class, I'm going to cover 2 sections, 5.1 and 5.3. This is it. This is all we have left. After this test 2, whenever y'all take it, all we have left are 2 sections, 5.1 and 5.3. I'm going to cover that next Tuesday. We do have one written assignment left. Let me close this up. Class assignment 2 is right here, y'all. This is one of those written assignments, like we had one class assignment 1 at the beginning of the semester. This is our second to last one. Okay, so I did put the instructions here on how to submit it. So once you finish, if you want to print it out, that's fine. Take a picture. Make sure y'all, and the only reason I said this is because this has happened before, and I don't know if anybody in here, our class did it, but I know this happens with like iPhones. If you take a picture and you send from that screen, it doesn't save it as a JPEG. It saves it as some kind of a weird file, and I can't open them up. So make sure you just like save it, put it in your photo library or whatever, and then send it, okay? And it should come out nice and neat. But make sure you have it either as a JPEG or you can, if you have like CanScan or something like that, scan it. Send it to me by Thursday, December 2nd. That's the week after Thanksgiving, okay? And then what I made, y'all, I have a video right here, and this video shows you exactly how to do that part right there, okay? So I made a video on how to do class assignment number 2. It's out of 5.3, but when we get to that part, it's a little bit messy, and I'm not having you do all the process. I'm just having you do one little part of it, okay? So that's what I was going to do next Tuesday, y'all. Once I cover that, if y'all haven't taken the test and you're like, you know what, I'm going to take it tonight, right? I'm going to take it tonight at like midnight or whatever. Once I'm done with 5.1 and 5.3, and there's like, hey, sir, can we go over this question? Can we go over that question? I'm definitely happy to do something like that too next Tuesday, okay? All righty. So if y'all don't have any other questions, y'all, we'll call it a night there. Like I said, what I'm going to do, I don't know if y'all heard or not, but I have 3 college algebra classes this semester. I have you guys, I have 2 online. So I'm doing a review session with one of my college algebras tomorrow, and I'm doing with a review session with the other one on Thursday. So what I'm going to do is I'm making a list of the problems that we did tonight. I was making a list and then I stopped. But I'm going to make a list of the problems we did tonight. And when I upload our video, I'm going to say, we did these problems in the review. When I do it tomorrow, I'm going to say, we did these problems in the review. I'm going to do the same thing Thursday. So and I'm going to send, like, I'll send this video out tomorrow morning. I'll send the one I'm going to do tomorrow night, probably Thursday morning. And the one I'm going to do Thursday night, I'll send it out that night. And you'll see, like, either in the title or in the description, it'll say, these are the problems that we did, right? So if you're thinking about, hey, can we go over this question, you might check there, and it might have already done that problem that you did, okay? So anywho, that is it for us tonight, y'all. Let me stop recording the session, and let's see, stop